In this video, we'll be solving this geometry problem involving similar triangles and angles. Here's the problem statement. Angle B is equal to angle C. Find x and y. And we have x and y here are the lengths of these segments EC and ED. Okay, so they give us some information here about, you can see these two triangles, ABE and DCE. There are two triangles here. We have the side lengths for some of them. We know that angle B is congruent to angle C, or ABE, or DCE, if you will. So what we're going to try to do here is we want to find x and y, and we see these two triangles, and immediately what we should be looking at is whether they are similar or not, and if we can determine that. So kind of what we want to get to here is are these triangles similar? And if we know that, we can then pretty easily find x and y using the ratios of the sides. So, and a similar triangle is just two triangles in which the ratios of their sides are the same and their angles are the same. They're just like scaled up or down versions of each other, as opposed to congruence. And we have a variety of different criteria or theorems we can use to establish similarity. Just like in congruence, we have SAS and ASA and all of that, or AAS and HL. So here we've got AA pretty much, and SAS, and we have SSS. Those are the three criteria we have for determining similarity in triangles. Let's go ahead and see if we can use some of them to figure out if these two triangles are similar. So we know that angle B is equal to angle C. Now there's also a hidden angle here that's also going to be equal. We've got the vertical or opposite angles here opposing each other. And those angles are going to be AEB is going to be equal to or congruent to DEC. So we can establish angle AEB is congruent to DEC because they are vertical angles. Yes, vertical or opposite angles. Okay, so that's the first thing we now know. So actually right there, we have got ourselves two angles in common. We've got angle B and angle C, and we've got angle AEB and angle DEC. So we have two angles now, which means we can use the AA, or angle-angle, similarity criterion to conclude that these two triangles, ABE and DCE, are indeed similar. So we know that, I'm going to write this here, by AA similarity, triangles ABE, and we use the tilde here to indicate similarity. Triangle ABE is similar to DCE. Okay, by AA similarity. Okay, so now that we know they're similar, we can set up a system of ratios here, or an equation containing some chained ratios to get us to the answers for x and y. So to set up the ratio, we have to look at which sides correspond to which sides on both triangles. So we see here we've got this long hypotenuse side AB. And here is AB and here's DC, which looks like the same thing, the hypotenuse side, with the angle on it. In the smaller triangle, it's side DC. So we know AB corresponds to DC. So we write AB over DC. Then we continue. We see AE over here. It's the length, the 30 side. It's the side that has the first opposite angle on it. Corresponds to, you can see pretty easily here, side DE, which happens to be one of the things we're looking for, the length Y. So we've got DE, or we have to write this in the correct order. We've got AE, the longer triangle is going to be, or the larger triangle is going to be on the top, and we've got DE, smaller triangle on the bottom. And finally, we have side BE down here, and C, the shortest side. So BE and CE. So we know the values for some of these sides, so we can go ahead and fill in those values inside this equation. So we know AB is 21, we just fill that in, over DC, which we know is 14. Now for AE, we know that's 30. We don't know the value for DE. We're trying to find that out. We're just going to put Y there for now. BE, we know is 12, and again, CE is the value X we're trying to find. So here we can see we've got this ratio right here, or this fraction, 21 over 14. So this can simplify, factoring out the 7. We've got 7 times 3, 21. We've got 7 times 2, 14. So this becomes 3 over 2. So that is our common ratio here. All three fractions in this equation setup will be able to be simplified down to 3 over 2, the common ratio, which tells us what y and x must be. Because we have the 30, we have the 12. So 30 is going to act as the 3, the scaled up version of the 3. So to get from 3 to 30, we must multiply by 10. Thus, we must multiply 2 by 10 to get to y. So that tells us we're going to have 30 over 2 times 10, which is going to be 20. So 20 is our value for y right there. It's our value for y. Okay, same thing for this final fraction. We've got the 12. So we have the 3 times 4 would give you 12, which means the 2 times 4 would give you x. So we have 12 over 2 times 4, which is going to be 8. So we've got our values for x and y. So x is 8, and y is 20. And right there, we've successfully solved this geometry problem involving similar triangles and angles.